Good day, class. Today we are going to talk about geometric sequence. But before we will have our discussion, let us have first our learning objectives. After this lesson, you are expected to be able to do the following. First, define geometric sequence, and then compute the nth term of a geometric sequence. Now, let us have an activity. This activity is called Fold Me Up. So for this activity, you are going to need a partner because one of you is going to do the folding of the paper and the other one is going to do the recording on the table. So here are the things that you're going to do. First, you're going to start with a big square from a piece of paper and assume that the area of the square is 64 square units. Then you're going to fold the four corners to the center of the square and find the area of the resulting square. Finally, you're going to repeat the process 3 times and record the results in the table below. Now, after doing that activity, you are going to answer these questions with your partner. Question number 1, what is the area of the square formed after the first fold? What about the second fold and the third fold? Second question, is there a pattern in the areas obtained after 3 folds? Question number 3, you have generated a sequence of areas. What are the first 3 terms of the sequence? And question number 4, using the pattern in the areas, what would be the 6th term of the sequence? So I'll just give you 5 minutes to answer these questions. Now your 5 minutes is up. Let's see if you guys got it correctly. Answer these questions. Question number 1, what is the area of the square formed after the first fold? Correct, it is 32. For the second fold, correct, it's 16. And the third fold, it is correct, it's 8. Second question, is there a pattern in the areas obtained after 3 folds? See, the first area is 32, second is 16, and the third is 8. Is there a pattern here? Absolutely, there is. I mean, if you look closely, the next terms are just simply the half or half of the preceding term. For example, your second term, which is 16, is half of your preceding term, or the first term, which is 32. 8 here, your third term, is half of your second term. So, is there a pattern? Yes, absolutely there is. You have generated a sequence of areas. What are the first 3 terms? So the first 3 terms are, of course, 32, 16, and 8. Fourth question, using the pattern in the areas, what would be the 6th term of the sequence? So the terms of our sequence are 32, 16, and 8. As I have mentioned before in number 2, that the pattern here is that you just simply get half of the preceding term to obtain the next term. So your fourth term here has got to be half of your third term. What is half of 8? That is 4. Your fifth term is also half of your fourth term. Your fourth term here is 4, so 1/2 of 4 is correct, it's 2. Finally, your sixth term. The sixth term is half of your fifth term, and your fifth term here is 2. So 1/2 of 2 is equal to 1. Hence, our sixth term of the sequence is 1. You guys get it right. Now, those pattern of numbers or sequence of numbers we have generated from that activity is an example of what we call a geometric sequence. Now, a geometric sequence, class, is a sequence of terms in which each term is obtained by multiplying the preceding term by a constant quantity we call a common ratio. Now, if you remember, the terms of the pattern that we have generated from that activity were that our first term was 32. Our second term was 16. Our third term is 8. You see, your second term is actually obtained by multiplying its first term, the first term of the sequence, with 1/2. And your third term here, which is 8, is also obtained by multiplying the second term, which is 16, to 1/2 again. Now you see there is a constant number here that we have multiplied to the preceding term in order to obtain the next term. Like for the first term, which is 32, we multiply it with 1/2, so we obtain 16. And for the third term, we multiply the second term to again 1/2, and then we obtain 8. Now this 1/2 here, or the constant number that we multiplied to our preceding term in order to obtain the next term, is what we call the common ratio. Now what if we are asked to find the nth term of a particular geometric sequence? Then we are going to use this formula. A sub n equals a sub 1 times r to the exponent of n minus 1, where our a sub n stands for the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Now to understand better how this formula works, let us take an example. Example number 1. What is the 8th term of the geometric sequence 60, 30, 15, and 15/2? So what we're looking for here is the 8th term of this particular geometric sequence. So what is unknown is our a sub 8. Now we identify the given of this problem. Now to identify the given of this problem, we're going to go back to the formula, which is a sub 1 equals a sub n equals a sub 1 times r to the exponent of n minus 1. Because we're going to need our a sub 1, our r, and our n in order for this formula to work. Now, first we identify the a sub 1. What is our a sub 1? But the first term of this geometric sequence. Now the first term of this geometric sequence is 60. Therefore, our a sub 1 is 60. Our common ratio, remember this, to find the common ratio of a geometric sequence, all you have to do is to divide the next term by its preceding term. So you may use the second term divided by the first term, or you can use third term divided by the second term, or the fourth term divided by the third term. And in this case, we're going to use our second term and our first term. So our second term is 30, so that's going to be our numerator, 30 over our preceding term, which is 60, or our first term. Now 30 over 60 is just equal to 1/2. So our common ratio is 1/2. Now to find our n is simply the term in which we are looking for. So what is unknown here is the 8th term. Therefore, our n should be equal to 8. Now we go over to the formula. A sub n equals a sub 1 times r to the exponent of n minus 1. Now our a sub n here should be a sub 8 because that is what we are looking for in this problem. Our a sub 1 is 60 times our r, which is equal to 1/2, and n is equal to 8 minus 1. This is now 60 times 1/2 to the exponent of 7. Now we can't multiply 60 to 1/2 to the exponent of 7 here yet, so we have to simplify this part here. 60 times 1/2 to the exponent of 7 is just equal to 1 over 128. Now 60 times 1 over 128 is equal to 15 over 32. Therefore, the 8th term of this geometric sequence is equal to 15 over 32. I hope you understand this one. Now let us have our second example. Example number 2. A certain culture of bacteria initially contains 1,000 bacteria and doubles every hour. How many bacteria are in the culture at the end of 10 hours? Now we have to remember first that the formula a sub n equals a sub 1 times r to the exponent of n minus 1 only works if the pattern or the sequence is geometric. So we have to make sure that this certain pattern here follows a geometric pattern. Now let's see. So our first term is 1000. And as stated in here, every hour the number of bacteria doubles. So if this is the initial number of bacteria, after 1 hour, this is going to double. Therefore, it's going to become 2000. And this is our second term, okay? And after 1 hour again, this number is going to double, and this is going to become 4000. Now this is our first term, second term, and our third term. Now clearly this sequence is geometric because we have multiplied a certain number to every preceding term in order to obtain the next term. And that number is 2, right? So 1000 times 2 is 2000. 2000 times 2 is 4000. Hence, first identifying the given, our common ratio is 2. Now, what is our a sub 1 or the first term? Our a sub 1 is the initial number of bacteria, which was 1000. Now, what are we looking for in this problem? What we're looking for in this problem is actually a sub 10, because we are looking for the number of bacteria after 10 hours. Since what we're looking for here is a sub 10, therefore our n has to be equal to 10. Now we go back to the formula as a sub n equals a sub 1 times r to the exponent of n minus 1. A sub n here is a sub 10. That's equal to our a sub 1, which is 1000. Our r, which is the common ratio, is equal to 2 to the exponent of n minus 1, which is 10 minus 1. Now this is going to become 1000 times 2 to the exponent of 10 minus 1 is 9. Now 1000 times 2 to the exponent of 9 is equal to 512. Now 1000 times 512 is equal to 512,000. Therefore, the number of bacteria in the culture after 10 hours is 512,000. Understand, class? Now, if you do not have any question regarding the discussion, then let's synthesize everything. Today, you just learned about the geometric sequence. That a geometric sequence is a kind of sequence in which every term is obtained by multiplying the preceding term with a constant number we call the common ratio. Now let's take one example of a geometric sequence. Let's just say 2, 6, 18, and 54. Notice that the second term is obtained by multiplying the first term, which is 2, with 3. You see, 2 times 3, that's equal to 6. And the third term is obtained by multiplying the second term with, again, 3. And the fourth term is obtained by multiplying the third term with 3. Now, this constant number that we multiplied to the preceding term in order to obtain the next term is what we call the common ratio. Now, what if we are asked to find the nth term of a geometric sequence? Then we're going to use the formula a sub n equals a sub 1 times r to the exponent of n minus 1. Let's remember that this is the nth term. Our a sub 1 stands for the first term of the geometric sequence. R is our common ratio. And n here is the number of terms. Now that you have learned about geometric sequence and how to find its nth term, do you think there is an advantage of learning it? And if you think there is, why do you think so? Pretty good answer. Okay, now let us have another activity, but this time we're going to divide the class into 3 groups. The first group is going to be the computers. For you computers, you're going to solve these problems here. Second group are the analysts. So for you analysts, this is what you're going to do, okay? You're going to imagine that you were one of the people in the human resource group of a certain company. All of you were asked by the management to create a salary scheme for a very important job that the company would offer to the best IT graduates this year. The management gave the salary range for good for 2 years, telling everyone in your group that whoever could give a salary scheme that would best benefit both employers and the would-be employees would be given incentives. So basically, you analysts are just going to make a salary scheme that will be beneficial for both the employer and the would-be employees. And here's the rubrics for your outputs. For group 3, you guys are going to become the editors. You editors, you're going to create a video presentation about what you've learned about our topic, which is finding the nth term of a geometric sequence. You may use any video editing app like Filmora, CapCut, Filmigo, KineMaster, and etc. And here is the rubrics for your output. Now let us have a short test. So you're going to finish all these. I'm going to give you like 10 minutes to finish all of these. So you're going to answer all these problems here. Now you're done with the test. This is your assignment or your homework, okay? Now that we're done with everything, let me leave you with a quote. Quote from Andrew Marwah. He said, "The effectiveness of work increases according to geometric progression if there are no interruptions." Thank you so much, class.